I will find it very, very difficult to believe that there's no questions, because what is happening today?
Quiz.
Quiz, yeah. Everybody's favorite hypothesis test quiz. Yay. I graded a good chunk of chapter 9, not everything yet. I didn't get through everybody's 9.5. I was trying to catch up as it came in. So there's no, are you guys out there? You guys doing okay? And no questions on anything? Shania's like, let's just have a party instead. All right. Okay. Okay. All right. I kind of set this up so that there'd be plenty of time. You know, let me give an example question. Can we do an example of this kind of thing? That's an example question. But all right, if you don't have any questions. Bum, bum, ba-dum, ba-dum, bum, 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 bum. Let me check one thing here. That's true, Jeff. That's true. All right, I don't care. I'm not going to change it up. All right. Bum, bum, ba-dum. All right. More people coming in. Did anybody come in now that has questions? Because nobody here currently has questions. We do have that quiz today. All right, sure, fine, okay. So we got a little bit into, I'm guessing everybody's completely ready for the hypothesis test quiz. Hypothesis test quiz. That's a weird thing to say today. So I'm just going to keep on going. We got a little bit into chapter 12, believe it or not, last time, because Jeff is weird and he's doing things out of order. So we're just going to keep on going through it. It's crazy. Let me see if I put up here, let's see, unit 12. There it is. Oh, that's all I got up there. Okay, okay. All right, all right. Let's see. Oh, let me make it all about me. There we go. That's better. Boom, there we go. Okay, good. All right, guys. So last time we got into correlation and regression, and we did this. I'm having a hard time moving on. I'm certain people have questions. I'm not sure what to do. Go ahead.
Practice quiz in the thing.
We didn't. No, we didn't.
Oh crap. Okay.
Yeah, because I'm evil. I'm so evil. Yeah.
We do on the worksheet, the hypothesis test worksheet, the one sample mean number 2, since we didn't finish it.
Oh, really? There's something we didn't finish?
Or did I miss it?
I don't know. Maybe, I don't know. Which sheet is it?
It's the last sheet, hypothesis test worksheet, one sample mean. Oh, I could turn my camera on.
Oh, is that the one about the pain reliever?
Yes, number 2.
Oh, yeah, you're right. We didn't do that. All right, let's see. I got which screen I can write on. I think it's this one. Doobie 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 doo. Do 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 do. All right, Jeff, stop singing. All right, here we go. Oh, that's good. That's perfect. All right. I will tell you this. I don't know. I don't particularly enjoy this fact, but I just realized that the quiz I have up there, I'm not going to redo it. The quiz I have up there does not include a hypothesis test for percentage. So that's not on the quiz today for whatever reason. It will be on the final exam. So I don't know how you feel about that, but it's the way it is. All the formulas are on the quiz. There's only 4 that I have on there. So we did this side. Am I sharing this correctly? Do you guys see this?
Yeah.
The worksheet? Okay.
Yeah.
So we did this side about women having babies. We did this side. Not too many men having babies, so I guess that's just people having babies. So number 2, we didn't talk about yet, and this is about a specific pain reliever for statistics students to help with that specific kind of headache you get after doing some hypothesis testing. Has anyone experienced that kind of headache yet? No?
Yes.
Does anyone have a dream about hypothesis tests coming to get you? Yeah? All right. The hose and the highs combination. I guess I should make that a ha. All right. Oh, I've got the wrong screen. All right, let me do this again. Sorry. Come here. Oh, so many buttons to push and so much shit. All right, hold on. There we go. All right, so read through this. Let me know when you believe you know what the claim is. And again, this sheet is up on Canvas. We did do this side, so you might have it sitting somewhere, but there it is for you. Another 157, another 157, another 157.
The claim is that the new drug developed supposedly brings relief in less time than the other one. So
Good to know.
mean would be less than 11.2.
Yes. I like it. So where is that? Is everybody cool with that? Anybody get a different claim? So this number here would never, ever, 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 ever show up in the claim because we establish our claim before we take a sample. So that would never show up in our claim. So where's it going to go? Is it going to go in for the ho or the ha?
Uh-huh.
I like it because it does not have an equal sign. So what's the ho going to be?
Greater than or equal to.
I like it. Which one of these tells me where my rejection region is going to be?
The ha.
Exactly. Always. Always. It's just the way we set these up. We could have set this up in so many different ways. And the whole idea with the equal sign means that this will always tell me where the rejection region is. I don't care what the claim is. The minute you write the claim down, forget that that's the claim. Forget it until the last step. Okay, I really want you guys with me. I'm going to try to remember some of the mistakes people have made from the ones I've graded so far. We'll see if I can do that. 1 or 2 tail test?
1.
Definitely. And which side?
The right side.
Left.
Left side. Because less than, so it's pointing that way. So it's going to be.
Oh, yeah.
In fact, that also answers one of my questions I had too.
All right, sweet. All right, cool. It's always good to know that what I'm doing is useful. I like it. Thank you. What tells me that I can cross out nothing? What do I have to check first for part B?
The 45 statistic students.
All right, I like it. And somebody else
Greater
tell me
than
why
30.
that's. Oh, okay, you got it. So first thing I check is it normal? And sure enough, the sample size is bigger than 30. It doesn't say it's normal, but the sample size saves my ass. Sample size saves my ass. Man, that's all I'm going to say. Blush. And then, so I know I can cross this out. Now, which one of these can I cross out? How do I check which one of these I can cross out?
Deviation is known, or standard deviation is known.
Which standard deviation is known?
Sigma.
What is sigma?
With the sample.
Yeah, the only
Population
standard deviation
standard
I see.
deviation.
The only standard deviation I see came from the sample. So you got to be really careful. I'm getting too many people saying on their homework, I know the standard. No, that doesn't make any sense. Doesn't make any sense. Which standard deviation, right? All right. All right. So sigma unknown. So what can I use? What do I have to use?
T-score.
T-score.
Yeah, so I can cross Z out. I got to use T's. I like it. A nice Irish breakfast tea. Yummy, yummy. Or maybe just boring statistics teas. All right, so I'll take a minute. What actually tell me that? So we know alpha is 0.025. What else do I need to know to be able to look up this t-score I want? What else do I need to know? Yeah,
If it's a
The degree.
1 or 2 tail test,
I like it. So it's a one-tail test. What else do I need to know?
The degree of the freedom.
I like it. Degrees of freedom. And what's the degrees of freedom?
44.
4. I like it. Is that on the T chart?
no.
Shit. No. So what do you use if it's not there?
40.
Good. Now let me know. You guys have got to let me know. Let me stop sharing this and share this other thing. Hold on. Oh my God, there's too many freaking screens of shit. Okay, here we go. All right. So I got 0.025 in one tail, and I want to stop at 40. Now, if you used 45, I would give you a pass. I'd be like, okay, that's fine, because it was pretty close to 45. But technically, you should go down to the next one. Somebody is chatting at me. Oh, all right, hold on. So pretty cool with that t-score. We're going to use 2.021, but if you use 2.014 in this situation, I'm not going to take a point off, right? Because I understand. All right, so let me stop sharing that. Let me move you guys back over there. Let me share this other thing again, and then let me ask the question that just came in. I'm sorry, answer the question. What's sigma? What does this symbol represent?
Population standard deviation.
Population standard deviation. So tell me this, how many standard deviations did this problem tell me?
One.
One. Oh shit, and where did that one come from?
The sample.
The sample there, that's it, that's all, that's why we don't know population standard deviation, because they only gave me one and it came from a sample, so it can't be the population one. Does that make sense, guys? So again, don't go, oh, I know the standard deviation, so I can use Z. No, t-scores were invented for when I only know the sample standard deviation. That's why they were invented. So it's not a question about, do I know the standard deviation? It's which standard deviation do I know? Okay. All right. All right, I don't know what's up with me. I'm in a strange mood. Oh. How's that different, Jeff? Oh, I don't know. So what did we get? I'm sorry, did we get something? I forgot. Yes, we did, and I've forgotten what it was. Can somebody help me out? What did we get? Scheisse. Too much happened between looking at this. Nobody wrote it down?
2.021.
Excellent. And how do I have to modify that? Because of what I see here? I'm not going to put this down here. That doesn't make any sense. Where is that, guys? Where is it in relation to the mean?
It's the negative.
Yeah, it's got to be negative. Okay, good. I like it. So another mistake I see is, well, there's a really weird set of mistakes going on. Like, all right, don't write this down. somebody will calculate their T star, and let's say that it's negative 2.5. Have I put that in the right place?
No.
I appreciate somebody, the expression on somebody's face was like, what? Of course I haven't put it in the right place. My God. So if you put it in the wrong place, you're going to get the wrong answer. Anyway, also, I see way too many people putting stuff down here and it's positive. That doesn't make any sense. It's below the mean, so it should be negative, right? What is this in the middle? What is this?
The mean.
0.
It's 0. It's what the mean would be if it was turned into a t. So it's 0. Shabow. So of course it's going to be negative if it's to the left of that. Yes. Okay, I like it. How do I say this in words? If, I don't know why I left all this blank.
If T star
T
is
star.
less than negative 2.021,
We can
then reject ho and support ha.
reject ho, support ha. Okay, I like it. All right, just bear with me for a second. This problem is so easy to get so deep into stupid little details. I completely understand. But I desperately want you to never lose sight of what the idea is. The null thinks it's in here. So how can I show evidence for the guy who thinks the null is wrong if I get way out here? That is what step C is saying, is where does evidence start to show that the one who thinks it's here is wrong? That's what step C is saying. So if I get a sample that's way over here, that is evidence that the one who thought the mean is here is wrong. Okay. Okay. So of course, now that we've set up where evidence starts, we see what we find. Did we make it far enough away? So that's why we calculate what's called, I don't know if I've said this phrase, to be honest, the test statistic. I'm pretty sure the book uses that phrase. That's just Z or T star. That's the test statistic. All right. And thankfully, the formula is the same for both Z and T star. They're both the same formula. So I need to know what X bar is. What was X bar? I think some of you guys need to use this. You're like, what?
10.4.
10.4.
10.4. I like it. What's S?
2.34.
2.34. A few people are not changing their standard deviation. You always have to. So the new standard deviation will be 2.34 divided by the square root of, what was it, 45? I think, yeah.
0.349.
Please speak up if anything happens up here that you're like, what the hell's that? Why did that happen? Why did you do that? Now's the time to ask. So now I can do my T star. It's 10.4 minus the number from there. 11.2 divided by the new standard deviation. And I get something. Let's see.
Negative 2.29.
And what is it?
Negative 2.29.
2.29?
Yeah.
All right. That makes sense. Okay. So now, if we put this in the right place, it should be a nice visual. No, I don't want to highlight something. Okay. Where's negative 2.29 go?
Past negative 2.021.
Yeah, I made it in there. So what can I do?
We failed to reject the ho and failed to support the ha.
Did we make it? Did we make it in?
No.
Yes,
Right there, did we make it into the rejection region?
yes.
Yes, we did. Right there, that's where I am, right? Negative
Okay,
two.
so
Oh, yeah, okay, because it's,
it doesn't have to be like close to the zero. It has to be where the rejection should be. I didn't understand that part.
Here's the rejection region right there. That's the rejection region, and we made it in. So therefore, we can do this. We succeeded.
Oh,
Yeah, so this is where evidence starts. I've got to get it. I've got to get past this to show enough evidence. Did we? Yes. If I was closer to this, that would be definitely not enough evidence to say the guy who thinks it's here is wrong. I've got to be out here to show evidence that the guy who thinks it's here is wrong. I really want this to make, so the hoe thinks it's here.
oh, because the T is like the T star is less than the 2.021 now.
Definitely, yeah.
Now I understand that.
Okay. Negative 2.29 is more negative than negative 2.021. So it's in there. Yeah, it's in there. Like ragu, that's an old reference. Sorry. All right. So I can reject. Oscar is sorry, Jeff. I can reject the null, support the ha. I still have people who are using the wrong word. Which one was our claim?
The ha.
The ha. And what did we do with the ha?
Reject it. Oh,
Oh.
support it.
Yeah. Do you see what I just did? Right? I answered the question. Then I went, what's the claim again? Oh, yes, the ha. So I'm going to use this language right there.
Wait, so if the claim ended up being the ha, how come we're supporting it when it ended up in the rejection region?
So the rejection region cannot reject both of these because they're opposites. What does the rejection region reject?
The ho.
Yeah.
Okay.
So we made it into the rejection region. So we found evidence
I
that the
understand.
null is wrong, which means we found evidence that the ha is right.
Okay. I understand.
Did we prove anything?
No.
No, we didn't prove shit. Which is basically life, kids. But we found good evidence to support this, right? So we can support the claim. So we have found sufficient evidence. This is how I write sufficient evidence. Suffivid. That sounds like that's the name of the pain reliever. Suffivid. Anyway, sorry. I'm sorry. We have found sufficient evidence to support the claim that, and then we lightly plagiarize, that they get relief in the meantime. I'm sorry. That they bring relief to stat students and brings relief in less time than the old one. There we go. I'll find it eventually. Support the claim that the new drug brings relief in less time. All right, so it'll work faster. Yeah, Corbin, because the t-score chart is nowhere near as detailed as the z-score chart, we can't really find p-values. Now, technology could find it all day long, right? So you can actually do a hypothesis test in the TI calculator and it will give you a p-value, and I don't care. Right? In the real world, you get your p-values through software. I don't care. What's more important is to understand what's going on behind the scenes. All right.
I have a question.
Yes.
So, for example, Let's just say that alpha was 0.05 and it was a z-score. How would you find it on the chart?
Oh, all right. Interesting. All right, so you changed two things, but let's see. Where'd you go? There you are. Okay. So if alpha was 0.05, we would have looked here for one tail, correct?
Right?
And then we just don't stop. If you stop, you get a t-score. If you don't stop, you get a z-score.
Okay. Thank you.
You're welcome. There it is. I didn't go all the way down. I was like, why do these look different? So 1645, 196, 2576. I mean, those should sound very familiar by now, right? Those are the big bad z-scores. I like it. All right, let me show this again. Whoops. Okay. Another thing with people, you know, in your homework, if you haven't done section 9.5 yet, well, that's bad. But have this sitting next to you. I have people not really doing the steps. So that makes it difficult for you to get the right answer, and it makes it difficult for me to grade it. So you have
Actually, I do have a question about one of the questions on 9.5.
yeah.
I had trouble once I got to the getting Z star. For some reason, I would get like 9 point something.
Sure.
So I don't know if that still counted or not. There was one number 101.
Yeah, there's two that you get. There's one where you get like 9.9 something, and there's another one where you get 11 something, I think. So it's not impossible. So I love that you are skeptical, and you should be. If you get a Z-score of more than 4 or something, that's like, what the shit? But is it impossible? Of course not. So I think you're right. I think 101 is one of them. I don't know. Look at this is a. Are you happy I didn't assign this? This is a problem, guys. Anyway,
Yeah, I
sorry.
saw that. I'm so glad that wasn't one of the questions.
I don't want to grade. I don't want to look at that. All
That's
right,
the
one of-
English part of the math class.
I know. You got English in my math class. You got math in my English class. Let's see. Was it 101 that was freaky? I can't remember.
I think so. I got a high T score. T star.
High T score. Let's see. 101. I could check real quick. Do. All right. Yeah, that's the one. You get like 9.9 something. Yeah.
Yeah.
Okay. So I think there's two that happens. So normally, especially if it's on one of my tests, I don't normally let that happen. So if you get a T score of like 26, it's like, no, something has happened. Something is wrong. I like to make mine a little more suspenseful. Because if you get a Z or a T of 9, I don't care what alpha is. That sucker is rejected. I'm rejecting that hoe. Okay. Anything else, guys? Okay. Just to remind you. Oh, let's see. Did I write on this? I don't think I did.
Oh yeah.
Yeah.
If the area isn't given, which assume it's 0.05, right?
If the what now? Sorry.
If the area isn't given, the
Oh, if the
area
alpha is not
significance?
given. Yeah.
Alpha.
Yeah. Then you assume it's 0.05 because that's the most used one. Yeah.
Okay.
All right. Anything else, guys? See, that was good, wasn't it? Everybody, I think Takesha asked the question. It's always a good question, right? A few more people seem to feel better about things. And then there might be a few people out there that are like, that didn't help me out at all, Jeff. I'm like, I'm sorry. Ask a question. We All right, I'm going to try to slowly ease into chapter 12. We did this sheet last time. Remember this? Holy sheet. We did this. Oh my God, I am really goofy. Help me. All right. These are the kind of questions I like to ask. Obviously, you got to calculate R, you got to calculate the line of best fit. We'll ask you, is it a strong correlation? And I think I told you guys that I would tell you, for example, well, let me see. Can I look this up real quick? Probably not real quick. Dadgummit, Jeff. Did I show you this? I can't remember now. I'm not going to find this quickly, am I? No, Jeff, you're not going to find it quickly, buddy. No, screw it. Anyway, so there is actually a table of R values that, depending on the size of the sample, it tells you what R value has to be, what your R value has to be bigger than to show evidence that there's correlation. So on the test or a quiz, I would put what that R value is, right? So I would say something like R's got to be greater than 0.456. So to get R of 0.5, that you found evidence of correlation, but it's weak as hell because it's just barely above 0.45. It's not close to 1. Does that make any sense? Remember, weak is further away from 1 or -1, closer to 0. Strong is closer to 1, closer to -1. Yes, maybe. You guys remember this? All right. So what we're going to do.
I have a question.
Yeah.
On that sheet that we just did, the reason is the reason why we put the 11 just because we predicted 11, or like I forgot.
Oh, I had to ask you the question. So I would ask you, what would you predict for somebody who studied for 11 hours? See, I created the question.
Oh, okay.
Just to show you what kind of question I would ask. Because once you create, all right, now here's something I really want you guys to get. Before we had this whole correlation thing, our best guess for what grade somebody made would be the average grade. That would be our best guess. Right? Your best guess for, in any situation is the average. That's the expected value. That's your best guess. If the R is big enough, this will give you a better estimate than the average would be. So can this estimate suck? Yeah. Will it be better than the average would be for your guess? Yeah. If R is big enough. So, all right, I think that's all I wanted to say. I'm not sure if I answered a specific question. Oh man, senility is hitting me early. I'm sorry.
R stands for correlation, right?
Yeah. R is the letter. It's actually the regression the correlation coefficient. It kind of comes from regression. That's why we use the letter R. Yeah. What it does, it stands for correlation coefficient, which is just the number that tells me how strong the relationship is.
Okay, thank you.
Welcome. What would R mean if it was -1? If R was -1 for a set of data, what would it mean?
Would it mean a strong correlation?
More than strong. I mean,
What does
huh?
sorry, what does R measure?
So R is nifty. The equation for R has in it the standard deviation for the X's and the standard deviation for the Y's. That's in the equation. So R is basically a two-dimensional standard deviation that's been normalized so that 0 means no correlation. Holy shit, I just said a lot. Shortcut for that is R is like a two-dimensional standard deviation. What's the standard deviation mean for a set of data? you would have your mean, and the standard deviation is how far away on average all the data points get from that mean. You guys with me so far? Right? Isn't that what standard deviation means, just for a set of data? It's how far away all the data points get from the average on average. So if the average was 10 and this is 11, that's 1 away, 12 is 2 away, 13 is 3 away. So if you average up how far the points are, you get the standard deviation. Let me stop for a minute. I don't know if you guys remember that. That's how we developed the formula for it. Was it's an average distance from the mean to all of the data points. Is that okay? Does that sound familiar? Half of my face is gone. Oh, okay. For correlation, this is so beautiful if you just let it be. For correlation, so for data, the mean is a number. For correlation, the mean is a line. R is sort of like how far away those data points get from the line. But the scale is adjusted, so R equals 0 means that there's no line. There's no line that kind of gets close to all of them. R equals 1 means they perfectly line up on the line. The distance from the line to the points is nothing, but they line up in a positive way. R equals -1 means the distance is nothing, but they line up in a negative way. So if I had a line, I'm sorry, a set of data points that were like this would be R equals 1. Yeah. If I had another data point suddenly show up, what happened? Okay, nothing. That was like right here, and another one that was right there. Now this would be like R equal to 0.9 maybe. I messed up my perfect condition I was in. Yes, maybe. And of course, the whole thing works. If it has a downslope, it would be -1. Put a few more points off the line. Now it's -0.9, right? So R equals 0 means there's no pattern. They're just all over the place. All right, let me stop for a minute. Okay, so it's a beautiful analogy. Line of best fit is like the average. R is like the standard deviation. Everybody hates my explanations. I don't know, is that? I can't even get a smile from somebody for that. Okay, that's fine. That's for me. All right.
Be so hard on yourself.
Well, I
Making
don't
us
know. I'm
sad.
just making assumptions because nobody's talking. So as a teacher, I always want to explain things well enough. As a student, sometimes people are like, I don't care, just tell me how to do these things. And,
No, that made sense to me.
okay, cool. I like it because I
Thank you.
want you guys to, I want you to feel like you can understand this, because humans made this shit up. So you're humans. We could all get on this together. But very often students just kind of assume, I'm not going to understand this. Just show me how to do a problem, and I'll, the more you understand it, the easier the problem is, right? You're like, yeah, Jeff, but understanding's not easy. And I'm like, I know. All right. But I love that analogy. Line of best fit is like the mean. R is like a standard deviation. It's just that the scale for R, we adjusted it. -1 means it's actually 0 distance. They all lie on the line. Here, let's do this. Let me open up my calculator. Where are you at? Where are you at? There you are. All right. Let me think. Yeah, let me pull you guys over here. Come on, you can do it, calculator. Calculator. All right, so this is going to be neat. So if you have your calculator handy, get it out. Let's do this together. If you don't, just watch. So let me go into my lists. Let me clear these lists. Clear. I hope I didn't need that stuff. Oh, well, it's gone. Okay. Now all right. So put in here 1, 2, and over here put 10, 5. Okay. What points did I just put in? I put 2 points in. What are they?
The coordinates.
What are they?
10 and 5.
No.
1 and 10
Points
and
have
2
two
and 5.
parts. Say again?
1 and 10 and 2 and 5.
Yeah, 1, 10, 2, 5. That's X, Y. You with me? So when you're doing correlation, this is the X's, this is the Y's. This is an XY table. It's all algebra shit, right? So these are just points, 1, 10, 2, 5. Can you figure out what the slope is right now?
Yeah.
Yeah, you have to, right? When X goes up by 1, what is the Y? What are the Y's doing? When X goes up by 1, the Y's do what?
Go down by 5.
Go down by 5. So what's the slope? There we go. I see it in chat. -5, right? It's what the Y's are doing divided by what the X's are doing. That's all slope is. Rise over run. Y's over the other guys. So slope is -5. I like it. Can somebody predict for me what if I put a 0 here, right? What the Y would be? Go with me for a minute, guys. So 2 is 5, 1 is 10. What would 0 be?
15.
15. Doesn't that make sense? And what's special about the point 0, 15? It is the
Y-intercept?
y-intercept. So what did we just figure out? We figured out the slope is -5. And we figured out that the y-intercept is 0, 15, right? So B is 15, correct? If these 2 points lie in a line. Now watch. If I do stat, calc, linear regression, right? What about me? Shut up, 8. We're doing number 4. L1 is my X's, L2 is my Y's. Calculate, look what we get. Sorry. Look what we get. Do you guys, some of you guys might realize if you had this calculator in math 90 and math 103 or whatever the hell you did, remember those problems? Oh, there's a line going through the point -4, 7, comma, 3, 2, find the equation of the line. Yeah, all you had to do is plug it in here and it would do it for you. You didn't know. Sorry.
Can you help me put in R again in my?
Oh, yeah. Does
What's
anyone
the
else not have their R? And by the way, notice, why is this not a surprise? I'll get you in a second, Nikisha. Why is this not a surprise? How many points did we have?
2.
2. Is there any line that would go through both points but miss one of them at the same time? Isn't that weird? If I have 2 points, R is always going to be 1 or -1 because that line is going to go through both points. Does that make any sense? 2 points define a line. All right, stay with me, stay with me. If you're missing the R, go second 0. Hit this button right here. So you go to the D section. Diagnostic on. There, see it? Diagnostic on. Enter, enter. And that's very boring. It says done. It's like, thanks. So you have to tell it to go back and do linear regression again. And now your R should show up.
Perfect. Thank you.
Sweet. Now, what's going to happen? Now watch this. What did we say 0 should be?
15.
So what if I put in here 0, 13? Can somebody predict what's going to happen when I do linear regression? Come on, you guys can do it. Will the line go through all those points now?
No.
No, good. So what's going to happen to R? It was -1. What's going to happen to R now?
It's not going to be -1.
Good. Give me a guess what it might become.
-0.9.
Sure, -0.9, I'll accept it, right? Yeah, definitely not 0.09. That's way too big of a step. This should still be, that's pretty close to what it's supposed to be. It's supposed to be 15. And our equation's going to change too, because now I want you to really understand what's happening. It's not going to try to make a line that goes through two of these. It's going to try to make a line that gets as close as possible to all three. So let's see what it does. Come on, calculator, see what you got. Let's see what you got. Calculate, give me some weird shit. Go. All right, look at that. Look at that. So the R didn't change by much because 13 is really close to what it was supposed to be. Yes. What happened to our slope? It was -5, now it's -4. B was 15, now it's 13.33. All right, I don't know if you guys, I don't know if this is helping anybody. I really want this to make sense. Start with perfect and then introduce a point that's off that line that's going to make R get a little bit small, a little bit closer to 0, wherever it was, because then it's not perfect anymore. I love it. So what if I go in here and I put a point that's really just freaking crazy? Like I'll put 3. Can anybody tell me why this is a crazy point? 3, 7. Why is that a crazy point?
Because now it's going in, it went down and now it's going up.
Yeah, it was going down from 13 to 10 to 5 to 7. Oh, shit. So now what should happen to my R?
It'll go back towards 1.
No,
Oh,
I put a point that completely bucks the trend. I really want you guys to be with me. So I put a point that's really far away from where the line would want to be at 3, right? So my R should go even closer to 0. So let's see. There we go. See, I screwed my R up a little bit more. Now it's gotten even further away from perfect. Now, just to really hammer this home, one more thing. If I would have made this 3, 1, is that better? Is that going to make my R go closer to -1 again?
Yes, but not as much.
It will go closer to -1, but I agree with you. It probably won't be as close as it was before. I have no idea if this is helpful for you guys. I really want you to see the details of what affects these. Actually got better. You never know. Yeah. Because that's actually kind of like closer to where it's supposed to be with the new condition. Anyway, it's freaky. But I could really screw it up if I put 3, 45. I mean, that's just insane. And that's just going to kill it. Sorry, real quick. Poor little thing. The R became positive now. Dang, that really messed it up. Anyway. Okay, maybe. So let me do this. Let me go back in. Let me take out this one, the last freaky point. Get out of here. You're scaring my students. Oh, scheisse. Jeff. I can't do this. There it is. Die. Okay, thank you. All right, now if I plot this, so my stat plot is on. If I hit graph, why don't I see anything? Somebody remember? How do I force the calculator to show me the data points? Anybody?
Go to Zoom.
Zoom?
Would it be Zoom stat?
Oh,
I like it. All right, so there. Isn't that, can you guys see that that's not a straight line? Is it really that far off from being a straight line? No, if this just came in a little bit or this went up a little bit, it would be perfect. That's why the R was still like negative 0.98 something. Remember when we did this one change? It's still really close to being a straight line. All right, and the last thing I'll do, if I do this and I tell it, I don't know if you guys remember this. I think I showed you this. No, Jeff. Vars function y1. All right, now when I graph it, it'll show me. There we go. Look at that. Isn't that beautiful? That's a thing of sheer beauty. That really shows it really well. All right, all right, all right. That's enough. That's enough. That's enough. I forgot what I was. No, I wanted to find something for you guys to try. Hold on. I don't know why I didn't put this up there earlier. It's too bad for me and you. Here we go. Is this? Oh, this is this. Is this a good thing to do right now? Why not? Let's do this. Yeah, I like it. All right. Maybe not. Sorry, hold on. No, I don't like that. All right, well, let's do this. Let me make up some data. All right. Let me turn off my background. There we go. Okay, bam. All right, now. So what I want you to do is I want you to get this data into your calculator, figure out the line of best fit, the correlation coefficient, and then get them both to graph on your calculator. Anyway, all right. Let's make up some data. See if we can guess what the answers are going to be. This is so dark here. All right. So let's see. Let's use this data here. All right, so let's use that data right there. I like it. Oh shit, you can't see it all. Shit. Sorry. So get this in the calculator, do linear regression, figure out the line of best fit, figure out the correlation coefficient.
Isn't it supposed to give you R when you click linear regression?
Did it not for you?
No, no, it didn't.
Yeah, somebody else had that same thing, and I stepped through it with them just a minute ago. You hit second zero, right?
Okay.
Second zero. Then hit the X to the -1 key because it's got a D above it. You want to go to the D part of the list. Are you with me? So what happened when you hit second zero? What shows up?
Now I'm on catalog.
Oh, good. Now hit the X to the -1 button. It's like the fourth button down. It's under math.
Oh, there it is. Okay.
One that's got a D on it. Now you should be in the D section, right?
Yep.
Days of the week. Now scroll down to diagnostic on and hit enter, enter. gonna be very anticlimactic. You actually have to go back in and redo the lin reg.
There
And
it is. Okay. Sorry, I didn't do it before because my calculator was giving me an error code again.
Understood. All right. So not surprisingly, this thing should come out pretty strong. There's only one point that bucks the trend, but the trend is not perfect already, right? But still, it's not too far off. You guys have all that data in there? It's not a lot. All right. So let me see, let me share this. Did anybody get the line of best fit yet?
I got negative 0.86x
Yeah.
plus 36.06.
36.06.
Right.
All right. Now somebody else tell me, did somebody else get the R value?
Negative 0.95.
I like it. Sorry. That's my head in the way. Would you say that's a strong correlation?
Yes.
Yes. Would you say what kind of correlation is it? I like it. You're like, I don't know what you want from me, Jeff. Is it positive or negative? It's obviously
Negative.
so. When I ask you to interpret R, you tell me R tells me that it's a strong negative correlation. Now let me ask you another question. Would you trust the line of best fit to make a prediction? What do you think? What does R tell you? Does it tell you you can trust the line of best fit to make good predictions? Does the R tell you there's a strong relationship between X and Y?
Yes.
Yes. So it tells you that the line runs pretty close to the data points?
Yes.
Yes. So does it say anything about whether or not you can trust the equation of the line to make predictions?
I think so.
Yes, totally. So the stronger the relationship is, the more I trust the line to make predictions. The more I'm going to trust the predictions the line makes. I guess I could say it like that to be more grammatically correct. You shouldn't trust Jeff's grammatical skills. All right.
We say it's positive because we're seeing if it's as close to the 1 as possible.
Well, it's definitely negative, right? R is negative.
Yes.
Yeah. So all that means is what direction is the line going in? And you knew that from the beginning, right? Because as the X's increase, the Y's are generally decreasing, correct? So that means this line is going to go in what direction? Up or down?
Somebody say to the left.
What? No. Am I not seeing some? No. It's going to go down, right? So when R is negative, the slope is negative. When R is positive, the slope is positive. R does not equal the slope, though, of course, right? Okay. So let's do this. I love you guys. So let's see. Here's what I got. Sounds like what some other people got. So now in the y equals, if I don't want to do the way I did it earlier, I could put, what was it, negative 0.86x plus 36.06. Now, if I hit graph right now, I get nothing. Stupid Jeff and stupid calculator. What did I forget to do? Well, I don't see anything. What good is this?
You have to zoom. Stat zoom.
Zoom 9.
For a minute there, I thought there's something wrong.
Everybody good? This is bodacious. Look how it splits those two right in the middle. Bam, bam.
How'd you get the little squares?
Oh, what do you have showing up?
I got nothing because I had to reset my whole calculator.
Oh no. So do second y equals. Is this turned on?
Oh, okay.
So go in, turn it on, and you can pick. I'm always a square because I'm always a square. So bam. And again, the blue line is the two-dimensional average of the data points, and the R value is related to the idea of a two-dimensional standard deviation. I like it. All right, let's do this. Let's have a little contest. You guys ready? Any questions on the one we just did? Is anybody, any questions?
Sorry, I know that I'm taking up time, but now I'm having little squares and not the line.
That's weird. Your line showed up before?
Yeah. But the calculator might be frozen. I'll figure it out later.
Did you update your line equation to this one?
Yes.
Ah, that makes no sense to me. I'm sorry, buddy. That is weird. Your calculator is like, I can only do one thing right at a time. So,
Seriously, I have to reset it every day after class.
man. You have a what kind of calculator? TI? What kind of calculator do you have?
It's a TI 84 plus CE.
Oh man, that's the best kind.
I know.
I'm sorry, man.
Yeah, it's a bummer.
You never know. All right. So the contest is this. All right. I want you guys to create your own data, make 5 data points. You ready? You can make up your own data. Make 5 data points. Right? Just make it up. And whoever gets closest out, the goal is to get as close as possible to R equal 0.5. Does everybody understand what I'm saying? So obviously you're not going to want something that lines up perfectly because that would be an R of 1. So you make 5 data points and you're trying to get R to be 0.5. So you put 5 data points in, you do linear regression to see what your R is. I have no idea how to, I've never done this live before with people. So we'll see how this works. See if I can do a good job. Come on, Jeff. You can do it, buddy. Oh, I suck. All right. Let's see. Oh, I suck. I suck really bad. Ooh, better. Oh, no. This is kind of neat. I like this. Ooh, I'm almost there. All right, I feel pretty good about that. I don't know. This is interesting. You guys understand what's happening? So when you pick 5 points, you're more than likely not going to be, oh, Corbin. All right, Corbin's got 1. What'd you end up? What was, did you get exactly 0.5 for your R, or what'd you get for R? 0.5, excuse me. All right. Yeah, okay, I got close. So 0.5, oh, just 0.5 perfectly. So what you got? Actually, wait, okay, I'll wait. Oh, shit, all right.
I got 0.48.
Not bad. 0.5197, I like it. Nobody's beaten me yet. And you're like, Jeff, you're the freaking teacher, shut up. I know. So I like this. And I used to make this like a extra credit thing, but this is nicer. I think this is better to do live. Does everybody understand what you're trying to do when you put 5 numbers in and it's not exactly 0.5? Do you guys get a feel for how to mess things up? Okay. Let me see. Kyle, who else got theirs? Kyle, somebody else just told me they got 0.48. I got 0.5039. That's if I worked on it a little more, I could probably get it better, but that's fine. I think that's pretty good. How's everybody else doing? How close have you gotten?
I got 0.59. I'm still working.
That's pretty good. It's a little weird, isn't it? It's kind of weird because it's weird to think 2-dimensionally, which is kind of like, well, we live in a 3D world, but if you change something, it actually might make it better, and you thought it was going to make it worse, because when you change something, it changes what the line is. That actually might get closer to some of the points, making the R get better. It's kind of neat. To be really honest, this doesn't really do a ton for you as far as calculating this kind of stuff, but I like to make people think about what R is measuring and how to affect it directly. Okay. All right. I don't really have much more beyond that, because I was kind of expecting to do a lot more review of chapter 9, but that's all right if nobody has to. I don't really have much more. I do want to say a couple things about the way the homework works. The homework gets a little bit freaky for this in the book, and I want to point that out. Let me point out a few things while I do this. I don't know, you guys can keep playing with that if you want to, but I'm going to talk a little bit. In chapter 12, I'm pretty sure I did 12, 1, 2, 3, and 5, I think is what I assigned. 12.1 is just a review of linear equations, slope and y-intercept and all kind of stuff. 12.2 is just plotting scatter plots. So 12.2, I actually do want you to do this by, I can't remember what they say, but it'd be nice if you did this by hand. Right. 12.3 and 12.5 you could do in the calculator. 12.3 is where they do the line of best fit. And they get that on the screen. Blah, blah, blah. Don't worry about, we're not going to do the equations and all that kind of stuff. Remember this guy? Oh, yeah. Oh, I told you I was going to only show you that once. I'm sorry. Let's look at some of the homework. Yeah, let's go here. Let's see, blah, 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 blah. Where's the get weird? Okay, these get a little weird. Yeah. So when they say find the correlation coefficient, is it significant? If you hit one of those, it's really, I'm just going to make it a subjective thing. Like, tell me this. If you got R of 0.3, does that sound significant? Does that sound like evidence of correlation if R is 0.3? No, probably not. Right? You guys know? Or if I get R equal 0.8, how do you feel about that?
A bit better.
Yeah, a lot better, right? And it kind of depends on the sample size. I know, but in the homework, just calculate the line of best fit, calculate the R value, and it's sort of a subjective thing as to whether or not it's significant. Okay. I'm pretty sure I cut out, you could make a whole hypothesis test about these, which don't worry, I'm not going to do that. So I'm pretty sure I cut that out of here. Okay. And of course, the idea of outliers is really easy with scatter plots and line of best fit, because whatever's really far away from the line is an outlier. We talked about that with the beer drinkers and the people, the one person who didn't drink anything and did really crappy on the test, and the other person that drank a lot and did great. They were outliers because they were so far away from the trend. You guys with me? So if you plot your line of best fit, any points that are really far away from it are outliers. Kabam. Beautiful way to determine outliers. Okay, I like it. All right. I'll tell you this. So the quiz is today. That's going to open up. I think I have it opening it up at 3, I think. It's due Wednesday, 10 a.m. It's due Wednesday, 10 a.m. So you got, well, from now until then, so you got plenty of time to find time to do it. I think I gave you an hour and 20 minutes to do it. That's probably more than you should need. On Wednesday, I'm going to put something up in Canvas that you're going to want to try to print out if you can. Some stuff about correlation. 1 or 2 things. We'll see. Yeah, there you go. And I think that's enough for today. That's plenty. What do you guys think? Again, it was really mostly for questions from to get ready for the quiz, but everybody's ready, so it's all good. So let me know if you need to hang out. Otherwise, you are free to go.
Actually, I do remember I do have a question.
Yes.
I remember seeing one of the questions, I forgot which one it was, but 'cause I did it differently. I think that the claim was M equals, I forgot the number, but and then I know on the, because sometimes I check the answers on some of the questions to see how close I got to it. The ha was like, it was lesser than instead of like not equal to.
Okay. Would you remember which problem? So
I'm trying to look for it right now.
okay. So you thought the ha should have been not equal to.
Yeah.
Okay. So it really depends on what the claim was. Because I mean, some of these problems kind of bury the claim a little bit, like this problem, the claim doesn't show up until right at the end, has increased. So that would be a one-tailed test, right? That would be the claim is mu greater, or I'm sorry, is this a, yeah, mu greater than 80, right? Let me know if you find it. Let me know if anybody else has questions too. Are you all just waiting to hear what this question is? Is that what's happening?
I didn't want to interrupt his but
He's taking a look. What you got?
okay. I guess I'm having trouble wording it when the claim fits under the hoe and the hoe is, I guess the claim is right. I guess the way, let me see.
So that's impossible.
Okay, so yeah, so like 107. Okay, well, okay, 107, the claim is percentage is less than 0.18. And let me see it. And it fell under, so we tested it, right? And it's not in the rejection area. Does that make sense?
Sure.
And I wrote, okay, so then, hold on, I'm trying to figure out how to word
If
it.
it's not in the rejection, you
Yeah, so
fail to reject the null. You fail to support the ha.
Say that again one more time.
So if it doesn't fall in the rejection region, that means we can't say the ho is wrong, which means we can't say the ha is right. So we fail on both counts.
Okay.
So if your claim is the ha, you would say we have not found sufficient evidence to support the claim that blah, blah,
Okay.
blah. Yeah. So basically, if the claim is the ho, it's the word reject. If the claim is the ha, it's the word support.
Okay, because I put, we have found sufficient evidence to reject the claim.
But you told me you didn't fall into the rejection region, right?
Yes.
So if it doesn't fall in the rejection region, we fail to reject the null. Bam.
Okay. Okay.
Yeah, I found the question.
Oh, which one?
Number 98.
Oh, let's see. All right, and what happened on this one? So right here it says a student believes that less than 40%. So that's your claim.
Yeah, so I put a less p equals less than or equal to 0.40.
Wait a minute. Did they say the student believes that at most 40%? No, it said the student believes that less than 40%. So does that student believe exactly 40%? If they believe it's less than 40%, could they believe that it equals 40%? If you thought
Yes.
sorry? No.
No.
If you thought that I was less than 40 years old, then you don't think that I am exactly 40 years old. You think that I'm less than. That does not, that would be p less than 0.4.
Oh,
There's no or equal to up there, is there? It's just less than, not or equal to.
okay.
Yeah. I think that happened a couple times to you.
Yeah, I forgot that.
Yeah. Sorry?
Good.
Good. What's up?
I have questions. So like 98. So level is like P. The claim is like P less like this
Less
less
than,
than
yeah.
0.40 not equal.
Good. Yeah.
But what is that then? Whole is like P equal 0.40. If the
Not
answer
really.
is,
I wouldn't say so. So if the claim is p less than 0.4, that goes into the ha, right?
yeah.
It doesn't have an equals. So the ho would be p, the opposite of less than, which is greater than or equal to.
But the answer is like that. So that's
I
why.
told you the book is weird when it comes to this.
Okay.
I told you we know better.
Okay, got it.
Yeah, that's how it got me.
So you guys got to remember when I try to point out that the book does things a little weird sometimes. So if you're checking your answer, you know to ignore that kind of thing, because I told you sometimes it makes so there is a school of thought by some statisticians that the null should always have an equal sign. And I don't agree with that. I'm in the school of thought that it should be the exact opposite. And this book kind of does both things. It's weird. So that's why I feel like part of it was written by somebody who believes one thing and the part was believed another thing anyway.
Actually, like 78. How to figure it out? Like standard deviation.
Oh yeah, you put these into list one and you do one var stats. Remember that set you calc stat calc one var stats, and then you get the X bar and you get the S. Yeah.
Is added and put those numbers on the
Put them into
one?
the list one on your calculator, right? And then you do stat calc the first thing, one var stats, one variable. Yeah, it'll tell you X
Okay, got it.
bar and N and all kinds of, yeah.
Is it too late to ask about study group tonight?
No.
Would we like a study group, please?
Okay, all right.
That's all I had. I'm leaving. So
Huh?
again, so I'm leaving. See you again on Wednesday.
Okay. Oh shit. Don't do that. All right. Oh, where is everything? Here it is. Okay. Schedule a meeting. All right. Let me see.
Thank you.
Sure.
All right, I'll go. Bye.
Yep. Study group, 6 p.m. Let me see. All right, I think that's everything. Let me see. 10th, yeah. 6 p.m. Okay.
I just didn't know if it was too late because you said you had started the quiz at 3.
Yeah, the quiz is going to start at 3. You got until Wednesday morning though, so nobody better join the study group that's taking the quiz at the same time. That's all I gotta say.
Gotcha.
Right? Yeah.
Yes.
And actually, nobody better join that's already taken the quiz.
Yeah.
Let's see. Who just came back in?
Me.
Sarah?
Why not?
Sorry, I
Yeah, I'm
don't.
leaving. Thank you.
Okay, sure.
Professor, so I did the homework like 9.2.
Uh-oh, you're kind of breaking up a little bit.
8.
Your Wi-Fi is getting.
Those
Say it again. Sorry.
8.9.2.
9.2. Sure. What about it?
And yeah, so I'm redoing the homework because I haven't been complete like almost all the homework. So if I finish the thing, can you check it? If I
You're breaking up a lot. I'm sorry.
ask you,
Your Wi-Fi is really bad.
Really?
Say it again. Uh-oh.
Oh, okay,
Breaking
okay.
up a
So
lot.
I'm redoing the homework now. The homework
Sure.
because my almost
Send me an email.
almost the
If you
homework.
Send me an email saying, can you check this over? Then I will.
Okay.
Okay.
Okay, got it. Thank you.
Sure.
Bye.